In this video, we're going to talk about how to calculate the probability for a binomial distribution. That means a distribution that follows the binomial experiment. So before we can get into how to do the probability, I need to introduce some notation. The first is this notation called a factorial. It looks like an exclamation mark. And its formula is you start with the number and you decrease by one until you multiply out till it gets to a one. So let's do an example really quick. 5 factorial. So 5 factorial would be 5 times 4 times 3 times 2 times 1. So you start with that number and you just keep decreasing by one, multiplying them until you get to a 1. Okay, so if I multiply that all out, that's going to come out to 120. Okay, so that's how we would calculate a factorial. Quick note, 0 factorial is not 0, it's actually 1. Okay, and we'll talk about that in a minute. Let's first talk about an example that uses the factorial. So how could I arrange 3 books? So let's say I have 3 books and I want to put them in an arrangement. Well, I could change the arrangement based on which book I set first or to the left, right? And then the one in the middle and then the one on the right. So I could kind of mix up the arrangement multiple ways. Here's how I could calculate how many ways I could do it. When I put the first book down, I have 3 books to choose from. And when I put the second book down, I only have 2 books to choose from because I put the first book down. It's there. The second book, the one that's going to go in the middle, I only have 2 options. And now when I get to the last book, it's chosen. There's only one option for the last one. And multiplying these 3 things together is how I could arrange the 3 books. Now, this is 3 factorial. So this represents a factorial, which by the way is 6. So there are 6 ways I could arrange 3 books. And this could get more and more complicated, like when you're talking about how many ways could I arrange 3 books, but I'm picking from 10, right? Like that can get like a lot more complicated. So I'm choosing out of 10 books, I'm going to pull out 3 of them and arrange them. So that can start to become very complicated when we're looking at counting techniques. Okay, let's move into another really important counting notation. And that is this definition of a combination. So if we choose R items out of N total items, like when I talked about picking 3 books out of 10 total books, okay, without replacement, and the order doesn't matter. The order that I grab the 3 books does not matter. That is called a combination. And a combination has a kind of complicated formula. These 2 are just notations to represent combination. So we're going to use this notation right here. That's the one we're going to favor. But this notation gets used a lot too, this parenthesis notation. N is how many we're choosing out of, and R is how many we're choosing. So N's the total, and R is how many we're picking. Okay, so let's look at an example and work out this notation so we can understand. So let's evaluate 6 choose 4. That's how we say that. 6 choose 4. So out of 6, we're choosing 4. Okay, that's what that means. So according to the formula, 6 factorial would go in the numerator, and then 4 factorial in the denominator, and then 6 minus 4 factorial. So here, let me write that out different. So that's 6 factorial, 4 factorial. So 6 minus 4, that's 2 factorial. Okay, so we have a bunch of factorials. Let's write them out. 6 times 5 times 4 times 3 times 2 times 1. And I could plug that into the calculator. However, I'm going to be clever. So give me a second and I'll show you what's clever. So 4 factorial is 4 times 2. Oh, sorry, 4 times 3 times 2 times 1. And 2 factorial is 2 times 1. And these are multiplied on the bottom. So I'll put a little multiplication symbol. All right. So here's what's nifty. I can cancel some stuff. So this 4 factorial actually cancels with all of that. Okay. And what I'm left with is 6 times 5, which is 30, over 2 times 1, which is 2, or 15. Now, it's possible to do this on calculators, and I will show you how to do that in a minute. Let's look at this example. How many ways can you choose 3 books out of 10 total? Okay, so this is kind of a riff on the example I talked about earlier. So we're just picking 3 out of the 10, which means the order that I pick them doesn't matter. I'm just going to have 3 books in my hand. So this is a combination. So what we'll be doing is 10 choose 3. So that would be 10 factorial over 3 factorial times 10 minus 3 factorial, or 10 factorial over 3 factorial times 7 factorial. Well, if I write this out, and I'm going to take the moment and write it out because things are going to cancel. Okay, 3 times 2 times 1, and 7 times 6 times 4. Okay, so the 7 factorial is going to completely cancel with all of this last part of the factorial up here. Nice. And I could reduce the 3 and the 2. I could reduce that. Here, I'm going to do that in a different color with the 9. So 3 could go into 9 3 times. 2 goes into 8 4 times. And that would leave me with 10 times 3 times 4, which is 120. So there's 120 ways I can pick 3 books out of 10 total. So many scientific calculators can do this. They have that ability. And it kind of varies on the calculator what it looks like. On some calculators, you may have to actually press a button that says stat or probability, more likely probability, PRB. On some calculators, it's actually on the screen. You'll even see an NCR, like that actually is possible. If you want to know, Google your calculator, your scientific calculator, and see if it's possible to do a combination. And you could kind of work that out on your calculator, which makes it a lot quicker rather than kind of writing out these factorials and doing the canceling. Okay, so here we go. We're going to go ahead and explore now, finally, the formula for the binomial distribution and calculating those probabilities. So here is the formula. The probability of obtaining X successes in N independent trials, what a tongue twister, of a binomial experiment is P of X equals N choose X times little p to the X, where P is the probability of success, and then 1 minus P to the N minus X. All right, so I know that kind of gets a little bit daunting to see, but let's step through this with an example, and I think you'll understand where the formula comes from, okay? So here we go. So let's say we have 4 people, and we recently found out that 34% of Americans are college graduates. So what is the probability that 2 of these 4 people are college graduates? So in this problem, P would be that they are a college graduate. So success, I guess in this case, let me write that down, is a college graduate. And the probability of success would be 0.34. So failure would be they are a college graduate, and that would mean that they are the complement of 0.34, which is 0.66. So there's a 66% chance that they didn't graduate from college. Okay, so out of these 4 people, let's suppose that we're interested in that 2 of them are college graduates. So that could kind of play out in different scenarios. And I kind of did this in like different ideas. And what we're going to do is we're going to figure out how we would calculate this probability. So let's suppose for the moment that Bill and Anna happen to be the 2 that are college graduates. Okay, that would mean that the probability that Bill was a college graduate is 34%. And Anna being a college graduate is 34%. And then let's say Juan is not. So that probability would be 66%. And let's say Mary is not. So that's also 66%. So that's how you'd calculate the probability. I'm not going to actually multiply that out, but I'm just going to write that out. Okay, so here, let's look at the next one. Let's say it was Bill and Juan that were the college graduates. So Bill has a 34% chance. Anna now would be the non-college graduate, so that's a 66% chance. Juan would be now the 34%, and Mary would be 66%. Now notice, what do you notice about these 2? they're the same, right? I mean, they're reordered, but they're the same. So what we're seeing is that regardless of who ends up being the college graduate versus who isn't, okay, um, we're basically just reordering the where the 0.34 gets assigned. Okay, so this is 66, 0.34, 0.34, 0.66, and we're going through all possibilities, and there's 6 total. And I mentioned that the reason there's 6 total possibilities is because we're picking 2 out of the 4, and that's 6 if you calculate that combination. So 0.66, 0.66, 0.34, 0.34. All right, and let's see, did I get them all? 1, 2, okay. So each of these comes out to 0.34, oops, I'm gonna write it as an exponent, 0.34 squared, wow, that's sloppy, times 0.66 squared. So the 0.34 squared is because we're saying 2 of them graduated, so that's a 34% chance. And the 0.66 is saying that the other 2 did not graduate, so that's a 66% chance. And so the 2s are coming from what we're assigning to be the people who were success versus the failure in this problem. The 6, though, the fact that we have 6 different outcomes means that we need to add this up every single time. I'm going to get really lazy on us and just do little repeat symbols. Repeat. So we repeat this 6 different ways because there's 6 different possibilities. So this comes out to 6 times 0.34 squared times 0.66 squared. That is the formula. The 6, remember, it came from me out of the 4 people. I chose 2 of them. That's, oops, I'm labeling the wrong thing. That's the 6. So this is how we calculate the probability that 2 of them graduated from college. And I'll let you plug that into your calculator. You can actually come up with a decimal. Let's pause and do that really quick. So 0.34 squared times 0.66 squared times that 6, that comes out to 30%. So there's a 30% chance this can happen. I got 0.302. Okay, so this is how the formula works. This counts how many ways we can choose this specific number, okay? So it counts all of the possibilities, all combos. Makes sense, it's a combination, get it? This counts the number of successes and their probability of occurring, which is X in this problem. X is how many they say were college graduate in that last one. And this is calculating all of the failures. Now, we're not saying, by the way, that being a college grad or not a college grad is a success or failure. It's just the way it was defined in that problem. So don't think that that's what I was trying to say. This was not me making a commentary. Okay, so let's look at a different example. So it is stated about 41% of adult workers have a high school diploma, but do not pursue any further education. So if 20 adult workers are selected, find the probability that 12 of them have a high school diploma, but do not pursue any further education. Okay, so let's try to calculate this. Let's see, this would be N in this problem would be 20. What we're counting as success is they have a high school diploma. That 12 of them have a high school diploma, yep. But don't go any further, okay? And then I'm gonna go ahead and calculate Q because that's what this part of the formula is. They are calculating Q right there. And they're just figuring out how many people are left over. That's what the N minus X is. How many people were not part of the quote unquote success. So Q would be 0.59. All right, so let's go ahead and calculate this. So this would be the probability of 12. So we're saying out of the 20 people, we're choosing 12 of them. And the probability that 12 of them are successful in this scenario is 0.41 to the 12. And then we're saying that the remaining 8 would be what we're counting as failure in this case, which, by the way, in this case, failure is saying that maybe they got a high school diploma and did move on, by the way, just so we're clear. Okay. It's just how we're defining failure in that problem. And that's how we'd calculate this. So let's go ahead and figure out what 20 choose 12 is. I'd pause the video if you want to do that calculation. I really encourage you to figure out how your calculator can do that. If you want to just trust me for the moment, I will tell you what I got, and then you can double check it later. But 126,970. And then I multiplied that by 0.41 to the 12, 0.59 to the 8, and I got, oh, I didn't calculate it. Let's do that really quick. So go ahead and plug it into your calculator and you can see what you get. 970 times 41 to the 12 times 0.59 to the 8. All right, so I'm coming up with 0.04, a 4% chance that 12 of them, exactly 12 of them, will have a high school diploma, but no further education. Only a 4% chance. Okay, now, as you can kind of tell, this can get complicated, especially if your calculator doesn't do combinations. Like calculating this can be a little bit annoying. So I want to show you how to do this calculation using Google Sheets or Excel. So let's go ahead and we're going to look at this problem here just so we can kind of get familiar with it. So number of trials is 15, chances of success is 40%. So they want us to find the probability that X equals 15. So we're going to use this doing Google Sheets first, and then I will also show you on Excel. So let me go ahead and swap over to my Google Sheets. Let me grab this. Okay, so here's what we're going to do. We're going to enter equals, oops, let me deselect all those columns. Come on, let go. All right. Okay, delete, 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 delete. I don't know. There we go. It's being stubborn for some reason. Okay, so equals. So if I start typing binom, there we come up with binom dist. That's a binomial distribution. Okay. It actually, I don't know if it really matters which one you choose. Let's just choose the first one. And it's telling me what I need to enter. So first, number of successes. So in that problem, they wanted 15 successful. Okay. Number of trials, it was out of 15 trials. All right. And 40% success. So 0.4. And then they ask about cumulative. Okay, so cumulative is if we're talking about it being bigger than or equal to that number. I'm sorry, less than or equal to that number. We're not, we're just wanting it to be equal to that number. So we're going to put false, okay? And that's going to calculate for us the probability that they would have exactly 15. Okay, tiny probability, which makes sense that all 15, right, have a 40% chance of success. Okay, tiny probability. So how many zeros was that? Let's see. 1, 2, 3, 4, 5. I think that's 6. Wow, it's really hard to tell. I'm going to grab it like that because it's so difficult to see. And let me come back here to my notes. And let's see if it'll let me paste it in. Control V. Aha, there it is. Okay, so that came from Google Sheets. And I'm just going to go ahead and put it like that. I do want to make a comment that some calculators do switch to scientific notation, especially when it's such a small number like this. They might write this as 1 times 10. So let's see, how many zeros were there? 1, I'm going to count them out with my cursor. 1, 2, 3, 4, 5 zeros. Okay, which means it would be 10 to the negative 6 if we were writing this in scientific notation. The calculators use E instead of 10, but that's what it means. It means 10 to the negative 6. Just as a commentary, some calculators switch to scientific notation when the numbers get very small like that. All right, so part B. Part B says, what about it being less than or equal to 15? Well, that's going to give us the opportunity to use that cumulative feature. Okay, so let's come back over here. And thank you. Let's go ahead and do this again. So binom distribution here. I'm going to check do the second one. Yep, same scenario. It doesn't matter which one you enter. Okay, number of successes 15, number of trials 15, probability of success 0.4, and this time we're going to put true. Yes, we want to know the possibility for all 15, and it comes out to 1. Duh. Because if we're saying that out of the 15, what's the probability that 15 or less than or equal to 15 have a chance of success? That's a 1. That's the case of 1. Okay, so really quick, I'm going to come back to my sheet. I'm going to write that down. So this ends up equaling 1, which makes sense. If this had been out of 16, it wouldn't be 1, just so you know. Okay, if they had been talking about this being out of 16, we would not have come up with 1. It would just have been whatever that decimal was. It would be a really big decimal, but still a decimal. So for part C, when they ask the opposite, that it's bigger than 15, well, that's absolutely impossible. It can't be bigger than 15, but it's the complement. It's the complement of this one up here. So we would just subtract it from 1, the complement, whatever we got in part B, we'd subtract from 1, which comes out to 0. Okay, so let's do a better example now that we kind of see how that works. This time I'm going to use Excel, okay, to work this out. But let's go ahead and step all the way through it, putting together everything we kind of talked about there. So we have 560 pages in a catalog, 8 feature signature artists. Suppose we randomly select 100 pages and let X equal the number of pages that include a feature artist. Okay, so the probability that a page has a feature artist, that's going to be, well, there's 8 out of 560. Okay, so we're actually, I think that's for part B. What is the probability distribution? Find the probabilities. Okay, so the probability distribution, they use this notation, X, and they use B for binomial. And then they state what N is and what P is. So in our problem, N and P would be 100 because they're picking 100. And the probability that they'd have a signature artist is 8 out of 560. So sorry, I skipped ahead to part B. Okay, so what values does X take on? So if we're looking at these 100 pages, we'd be saying that maybe 0 have the signature artists, or 1, or maybe 2, all the way up to 8, because there's no more than 8. There's only 8 that have. So it's possible that all 8 pages are in that 100, right? But that would be the values that X would take on in this problem. Okay, so we're going to use this to answer the questions. Probability that 2 pages feature signature artists. So they're asking for the probability of 2. So we're going to use Excel this time, and we're going to find this probability using the binomial distribution. If you don't have Excel, you can just use your Google Sheets and go through that with me. But let's go ahead and let me share my page for Excel. Okay, so very similarly, if I hit equals and I start typing binom, all right, it pops up binomial distribution right here. So if I hit enter, oops, it was going to want me to put the information. Okay, tell me what information you would like, please. Equals binom dist. Usually it will tell you. There we go. If you put the parenthesis, it'll tell you. Okay, so number of success, that's what they're saying for the first one. So we were saying 2 out of 100 with the probability of 8 out of 560, which I'm just going to put it right in like that. Excel understands. And then whether or not we want it cumulative. Oh, again, true or false. So false, we just want it equal. Okay, in this one. And there we go. So about 25% or 24.7. So 0.247. So let me go ahead and write that down. 0.247. Okay, so now I should mention, just so that you know, it might be wise to write what we just plugged in to either Excel or Google Sheets to actually write out. The binom dist came out. We plugged in 2, 100, 8 out of 560. And then we put in false. It might be wise to put that down on paper just so that it helps with like partial credit. So 0.247, that's what we came up with. Okay, so this one says, find the probability that at most 6 pages feature signature artists. So this would be at most 6. So that means it could be 6 or it could be less than 6. So that's how we'll notate this. X is less than or equal to 6. So in our program, we're going to use binom dist, and we're going to put in 6, 100, 8 out of 560. And this time, we do want the cumulative, so we're going to put true. All right, let's do that. I'm going to use Excel again for this. So equals, oops, I got mad because I clicked on the sheet. There we go, equals. Okay, so binom dist parentheses. Okay, so 6, 100, 8 out of 560, true this time. And wow, okay, so 0.99939, so 4. I'll round that to 0.994, or 3 nines. Oops, I'm sorry, I bumped the page. Equals 0.999. Actually, here, I'll just round it to 3 decimal places. That's what I did in the last problem. Okay, so for this one, they want to know the probability that more than 3 pages. So more than 3, that's different. That's finding the probability that X is bigger than 3. Well, that's not the complement of what we just found above. So I'd actually have to find first, I would have to find that it is less than or equal to 3. So I'd have to do that first. Okay. So that would be binom distribution. And we would be doing 3, 100, 8 out of 560, and true. Now, I encourage you, I'm not going to do this just for time. Plug that into Excel or Google Sheets. Figure out what that comes out to. So pause the video, do that really quick. I'm going to tell you what I got when I plugged it in. I got 0.944, if I'm rounding to 3, okay, which is going to be 0.056 when I calculate it. So that's how we would calculate that. I do want to make a note really quick. I know the textbook uses a notation, and sometimes others do too, and it's based on a notation from a calculator. Rather than write out binom dest and then the false and the true, they will often write out Binompdf for binomial probability distribution function, and that represents the non-cumulative when we're saying it's equal to some value, okay? And then they'll write the number of trials, the probability, and then the success. That's a notation I saw in the textbook. When they are doing the less than or equal to one, when it's less than or equal to a value, they write binom CDF and then NPX. So if you look in the book or see on somewhere else where they do this PDF, CDF, that's cumulative versus the equal. Okay, so the true versus the false. This would be the false. This would be true in the programs Excel or Google Sheets. Okay, and I just wanted to make a note of that really quick before we continued. Okay, so use the formulas, calculate the mean and standard deviation. So we haven't even used these formulas yet. That was that the mean equals n times p. So in this problem, we are taking n to be, 100 times 8 out of 560, which comes out to 1.4. So that means on average, this is an expected value. We expect when they pick 100 pages that about one page will include one of these signature artists. Okay, that's what that means. And then the standard deviation is going to be the square root of 100 times 8 out of 560. And now, sorry, the formula is the square root of NPQ. Sorry, Q in this case would be, well, we'd have to calculate how many pages don't have the signature artists. So if you do 560 minus 8, that comes out to 552. And that's the probability they don't have a signature artist. And when you plug that into the calculator, 1.19. All right. So let's try this again, just to make sure we got it. The lifetime risk of developing pancreatic cancer is about 1 in 78, which they went ahead and calculated as 1.28%. So it really isn't 1.28%, but we'll just use that approximation. I know we can use a fraction, but because they gave us this percent, that's what we'll use for the problem. They'll probably base their answers on 1.28%. Okay, so suppose we randomly select 200 people. Let X be the number of people who will develop pancreatic cancer. So what is the distribution? So this is that notation where they write the B and so we're saying it's a binomial distribution. Our sample size is 200 and our probability of success, which sadly in this case is pancreatic cancer, is 0.0128. Okay, so let's calculate the mean and the standard deviation. So the mean is n times p, which is 200 times 0.0128. Take a second, plug it into your calculator. I'm getting 256. Okay, standard deviation is the square root of NPQ, or the square root of 200. Oh, it's 2.56. I'm sorry. I just realized it is 2.56. Sorry, I just caught that. And this is 0.0128. So I have to do 1 minus 0.0128 to figure out the complement of that, the probability of failure. So I'm getting 0.9872. All right, so we're going to multiply these. I'm actually going to do this live because I didn't do it ahead of time. And take the square root of that. I am getting 1.59 when rounded. Okay, so use your calculator to find the probability. So we're not going to use a calculator. We're going to use Excel or Google Sheets, okay? So to find the probability that at most 8 people, so that's no more than 8, so 8 or less. So X is less than or equal to 8. So plugging this in, we would do the binomial distribution, and then we'll do 8, comma, 200, comma, 0.0128, comma, true. So take a moment, plug that in. And if you do it, you should get 0.9988. Just do 4 decimals. Is it more likely that 5 or 6 people will develop pancreatic cancer? Justify your answer numerically. So they want us to find the probability that X is going to be 5 and then compare that to the probability of it being 6. So this time we're going to do false. So we're finding exactly at 5. Okay, so 5, comma, 200, comma, 0.0128, false. We'll plug that in. And then we're going to do the exact same thing. I don't know why I'm putting equals 6, but whatever. 200.128, false. Okay, so plug those in. And make sure you get the same thing I'm about to write. If you want to pause the video. I'm getting 0.0707 and then 0.0298. So 5 is more likely. So this one's more likely. It just has a larger probability. So the answer would be 5 people.